Lesson 7.11, find points given slope of tangent line. So there's three different cases you're going to see. Sometimes they want you to find a horizontal tangent line, sometimes a vertical, and sometimes a diagonal. And so we need to know what slope horizontal lines have. So when I have this on a graph, we know that that has 0 slope. The nice thing about this lesson is they give us the equation and then they go ahead and give us what the derivative is. They're not expecting us to do that part because we should already know how to do it. But we're trying to find all the coordinate points on the curve where x equals -1 and the line tangent to the curve is horizontal, or state that no such points exist. So it's possible that we don't get any points. Let's try it. So step number 1, you're going to take the derivative that they're giving you and set it equal to what slope do we want that to come out to? Well, since it's horizontal, it needs to come out to be 0. So let me just show you something. If you had y plus 2x over -x plus 2y, and we want that whole thing to come out to 0. Think of a proportion. Think about this 0 is over 1. You would cross multiply 0 times this whole denominator, and that would just make 0. And then you would have it equal to this. So really, all you need to do is set the numerator equal to 0. Does that hopefully make sense? You could also think of it as multiplying by this denominator, multiplying by this denominator, that goes away. And so you're really just solving this. And then what I want to do with that is I want to plug the x value in they're giving me, which was x equals -1. So I would have y plus 2 times -1 equals 0. That would be y minus 2 equals 0, or y equals 2. So now that tells me the point is at -1, comma 2. I have to check it though to make sure that is actually a point of my function. Again, you won't have this graph, so it won't be that easy. We need to plug it into the original. So I would have a negative of x times y minus 5 minus x squared equals negative of y squared. That would be 1 times 2 is 2 minus 5 minus 1 equals -4. That would be 2 minus 5 is -3, minus 1 is -4 equals -4. That is true. So not only was I able to get the slope right, but I also figured out that is actually a point on the graph. So that is true. So it just wants the coordinate points where it has that specific x value and the tangent line has a specific slope. So our answer is going to be the point -1, 2. And now you can look at the graph. See, -1, 2 does exist there, and it actually is here at a minimum, so it does have a horizontal tangent line. Pretty cool. All right, number 2. Oh my goodness, I forgot to change the numbers again. I do a lot of copying and pasting when I make these. Okay, so we've got new equation. Luckily for us, they give us the slope of it. Find all coordinate points on the curve where y equals -1. And the line tangent to the curve is vertical, or state that no such points exist. So when I have a vertical tangent line, I know that vertical lines have undefined slope. Okay, so number 1, I'm going to take their derivative rule and set it equal to what I need to. Okay, so I'm trying to make this be undefined. What I want you to think about is anytime you calculate slope, which is a fraction, and you get like a number over 0, that's undefined. Okay, so really think about if I cross multiply this, this would make 0 times this is 0 here, 1 times this would be this. I'm really trying to figure out where is the denominator 0. So I'm really just setting denominator equal to 0 is all you need to think. Because remember, when the denominator is 0, that's a problem. That means something is undefined or there's a hole or something. So I'm going to take -x minus 3y squared, set it equal to 0. They're giving me a y value of -1. I'm going to plug that in. Solve for x. That would be 1 times -3. X is going to equal -3. So my point is at -3, -1. But now we have to check into the original. So it's 4 minus -3 times -1 minus -1 cubed plus -3 equals 0. Okay. That would be 3, but times a negative makes it a negative again. That would be a -1 times -1 is +1, minus 3. 4 minus 3, 1, plus 1 is 2. 2 minus 3 is -1. -1 does not equal 0, so no such points exist. And that'll just be a choice on your drop-down menu. And you can see from the graph here that when y is -1, it would be happening here. Let's see. And that was at -3. I don't even see a point. Let's see here. Oh, yeah, I think this graph's off a little bit. But there's no point here to have a vertical slope. I guess I should say that we found -3, -1 is where it would have to be, and that doesn't exist on our graph, so that's why there's no points that exist. Okay, and then there's one more that has a diagonal tangent line. We've got a new equation. They're telling us the derivative formula. Find all coordinate points on the curve where x equals -2 and the line tangent to the curve has a slope of -4/3. So they're just giving us some value for the slope, or maybe no points exist. So let's go ahead and take our derivative formula, set it equal to -4/3 slope. Okay, I always make the negative go with the top number of my fraction, so I'm going to cross multiply. So I'll have -4 times -x minus 2y equals 3 times y minus 2x. I'm going to distribute. Then I'm going to plug in x is -2. So 4 times -2 plus 8y goes 3y minus 6 times -2. -8 plus 8y equals 3y plus 12. Subtract 3y from 8y is 5. Add 8 to 12 is 20, so y is 4. So my point is -2, 4 is what it should be. Now I have to figure out, does that point really exist? So I'm going to take my original function and plug it in. So that would be +8 plus 4, so that side gets 12. That would be -4 plus 4 squared is 16. Minus 4 is 12. Checks out. So yes, this point would be my answer. And you can see right here at -2, 4, there's the point, and it must have a slope of down 4, right 3 for the tangent line.